In the previous video, we built the front-end JavaScript that displays the visitor counter on the web page. But that JavaScript alone doesn't actually know the number of visitors. It just calls an API to get that data. So in this video, I'll walk you through how I built that backend API using Python, Flask, and Google Cloud Run. This is the part of the project that connects everything together. It's like where the front end meets the database. So for this task, I decided to use Flask. It's a lightweight Python framework that's perfect for small web APIs. It's kind of simple and easy to set up, and it integrates nicely with Google Cloud services. So if you take a look at the code, at the top, I imported the required libraries with these. And then the most important ones here, the Firestore, that's Firestore, which is our database, and Flask, which helps us handle the incoming web requests. Then I also imported Flask calls, which allows requests from different origins, for example, from my public website. And next, I initialized the Flask app and enable calls for all routes with this. Basically, this means that any browser or front end, like the JavaScript we wrote earlier, can safely call our API without being blocked by the browser's same origin policy. Let me talk a bit about the cause error. It's if you've ever tried to call an API from a front end hosted on a different domain, you've probably seen that scary browser error, cause policy. It says like no access control, allow origin header present. So basically it's your browser saying, hey, this site is trying to fetch data from another domain and I'm not sure if it's allowed. So in my case, my front end was hosted on cloud storage, but my API was deployed on Cloud Run, which are two different origins. So without handling calls, the browser would block the API requests. The call stands for cross-origin resource sharing. So to fix this, I used the Flask calls package, and it automatically adds the right headers to my API responses, like access control, allow origin, which it tells the browsers that it's okay to accept responses from anywhere. So for development and testing, I allowed all origins, but in a production environment, ideally it's better to limit that to just your front-end domain for security reasons. So next, I initialized the Firestore client using this. And then this line basically connects our Python app to the Cloud Firestore using the default project credentials available inside the Cloud Run environment. Now, the main part of this app is the route function that handles the get and post requests. So when someone visits the website, this endpoint is called. Inside the function, I reference a Firestore document like this. Think of this like navigating a folder structure. There is a collection called views, and inside it's a document named counter. So that's where we'll store our count. The function then tries to retrieve that document from Firestore. Then if the document exists, that means someone has already visited before. Then I take the current count, increment it by 1, and update Firestore. But if the document doesn't exist, meaning this is the very first visitor, I create it and set the count to 1. Finally, I return the new visitor count as JSON. So that's what the front end receives and displays on the page. And I also included some error handling, so if anything goes wrong, like a Firestore connection issue, the API returns a proper response with a 500 status and logs the details for debugging. So writing the Flask app is only half the work. The next step is deploying it to Cloud Run, so it's publicly accessible. So for that, I containerized the app using a Docker file. I built the image and then pushed it to Google Container Registry. Then I deployed it to Cloud Run. That's the same endpoint you saw in the front-end code earlier. So if we jump into the Google Cloud Console and take a look at how I deployed the API on Cloud Run. On the Cloud Run dashboard, you can see my service. It's called Visitor Counter. So Cloud Run automatically gives each service a unique HTTPS endpoint, which you can see right here at the top. That's the same URL my JavaScript fetches data from in the front end. So every time someone visits my site, the request goes straight here. Then if I click into that service, we can see more details like the region, which in my case is set to US Central 1, and the service account that's running it. If I click on the logs tab, you can see incoming requests in real time. So each time someone loads my webpage, Cloud Run spins up the container, executes the Flask function, updates Firestore, and then returns the new count. So it's all automatic, no manual setup, no server maintenance. If we take a look further under the observability tab, Cloud Run integrates directly with login and monitoring. So here I can see real-time logs of every request that hits my API, including the request method, response time, and the status codes. So this makes debugging super easy. For example, if someone's request fails, or if there's an issue with Firestore, I can come here to check the logs and pinpoint exactly what went wrong. There are also metrics for CPU, memory usage, and the request latency, which gives me visibility into how my container is performing over time. Basically, I get full observability out of the box, no extra setup needed. If we take a look at the revisions tab, every time I redeploy a new version of my container, Cloud Run automatically creates a new revision. So you can think of revisions as snapshots. Each one represents a specific state of my service at a given time. If something breaks in a new deployment, I can easily roll back to the previous revision with a single click. So it's a really safe way to test updates without losing a working version. So if we check out the source section, this shows where my code or container image came from. So in my case, it's linked to a container image stored in Artifact Registry, but if you're using Cloud Build or GitHub integration, you can actually connect Cloud Run directly to your repo. So every time you push new code, it automatically builds and redeploys the service. That's actually handy for automating CI/CD workflows and keeping deployments consistent. So one thing that took a bit of troubleshooting was the permissions. By default, Cloud Run services run under a service account that doesn't automatically have access to Firestore. So I went into IAM and admin on Google Cloud and gave the Cloud Run service account the data store user role. So this allows the API to read and write data to Firestore successfully. Once that was set up, I deployed the service again and tested it in the browser. So each time I refresh the site, I could see the visitor count incrementing, which means the entire pipeline is working correctly. So the front end JavaScript calls the Cloud Run API, which talks to Firestore, increments the count, and returns the new number. And basically that's how the backend side of the visitor counter works. So in the next section, I'll show you a bit how I set up Firestore itself, how I created the collections, initialized the counter document, and configured security rules, so only my API can update it.